we've been asked to differentiate three functions that all have an integral defined part. So we have some integral defined functions. This one's actually the product of an integral defined function with the function x. We'll get to that in a moment. But we'll definitely need to know the fundamental theorem of calculus part 1 to be able to do this. And what it says is that if I have an integral defined function, its derivative is the function that is the integrand, right? That the derivative is f of x. So in this first one, I just have a function that's built exactly like the fundamental theorem of calculus part 1 says. And so dy dx, or y prime, is just the square root of 1 plus x squared. Nothing really to think about there, right? That's what this integral defined function is built to be. It's built to be the antiderivative, or an antiderivative, of its integrand. So now we look at number 2, and it's kind of similar. It has that 1 plus t squared under a square root. It's in the denominator this time. But what's really the big deal is that it's not from a constant to x the way the fundamental theorem of calculus part 1 is written. It's more like it's written from a constant to some function u on the variable x, right? This is really a u of x up there. Well, we've replaced x with a function on x. We have to use the chain rule. So we just followed the rule we've established here. Instead of f of x, though, it will be an f of u. And because of the chain rule, we'll have a times a du dx. And so that's the fundamental theorem of calculus part 1 with the chain rule. So now I look at this one, I would have a y prime equals 1 over the square root of 1 plus sine squared x times the derivative of sine is cosine x. I'm going to write that as one fraction, but we're just using the chain rule along with the fundamental theorem of calculus part 1. All right. One more problem in this set, and this one's at least a little interesting. I see the same idea where I have to use the fundamental theorem of calculus part 1 along with the chain rule. But there's also something else going on. It's a function that's integral defined multiplied by another function. I'm going to have to use the product rule. X times this function. The product rule says I have the first function times the derivative of the second function. So right now, I'm just going to take the derivative of this second part, this integral defined function. So I have to use the fundamental theorem of calculus part 1 along with the chain rule. So I'd have sine of, and I plug x squared in for t, and that would be an x to the 6th, times the derivative of that inside function, 2x, plus the second function times the derivative of the first. So this is a bit different because the second function, well, that's integral defined. Times the derivative of the first, well, the derivative of x is 1. And so my final answer is itself integral defined. I have x times sine of x to the 6th times 2x. Let's go on and get that out here. 2x squared times sine of x to the 6th plus, well, just that bit. All right, there's my derivative. Using the product rule along with the fundamental theorem of calculus part 1 and the chain rule.